An incredible phenomenon is occurring at this instant within our star's domain. A traveler from distant realms, a wanderer originating outside our solar boundaries, is hurtling across our vicinity with astonishing velocity. Recent findings from the past several days are reshaping all our previous assumptions regarding this enigmatic entity. In this session, we delve into the most recent astonishing disclosures concerning Comet 3 I/ATLAS. We will examine fresh photographs uncovering odd aspects of its conduct, explore an orbital interaction with the gas giant that might reshape its route indefinitely, and reveal information prompting experts to doubt if this body is genuinely as it seems. This narrative is evolving at present. By the conclusion, you could be pondering the identical query that stargazers are discreetly posing among themselves. However, prior to proceeding deeper, ensure you press that join button and activate alerts. This tale advances every day, and missing subsequent developments would be regrettable. Plus, if this captivates you, press that thumbs up to assist fellow enthusiasts in uncovering this stellar enigma. Novel snapshots taken from November 22nd through 24 have disclosed elements that stargazers did not anticipate. Employing robust observatories worldwide, from European sites to South American locations, sky photographers have recorded 3 I/ATLAS with exceptional clarity while it persists on its voyage across our stellar family. The standout photo originates from an astronomer using a moderate-sized instrument. Its content is remarkable. The wanderer exhibits an enormous luminous envelope. Yet this is the point where matters become peculiar. Projecting from the core are dual notable elements that ought not to appear so evident. A plume extending a staggering 5 million kilometers distant from our central star. And now the odd segment. A counterplume directed straight at our luminary spanning more than 1 million kilometers. Pause to consider this briefly. This inward counterplume is forcing its way against the stellar breeze, a flow of energized fragments streaming from the sun at 400 kilometers each second. For substances from this wanderer to advance that distance opposing such formidable resistance, the underlying mechanics are astounding. The dynamic force necessary indicates particle concentrations 1 million-fold denser than the stellar breeze alone. What is triggering this atypical action? Assuming 3 I/ATLAS represents a standard icy rock body, the figures narrate a surprising account. Estimates indicate it is shedding countless billions of kilograms of substance, potentially exceeding 10% of its overall bulk over merely 60 days. Such is not ordinary for these icy visitors. It represents an entirely distinct category. Furthermore, the puzzle intensifies upon examining its course. Updated assessments have verified what certain scholars presumed yet wished was false. 3 I/ATLAS demonstrates acceleration beyond gravitational forces. This exceeds the sun's pull or planetary influences on its circuit. An element is dynamically modifying its spatial route. Moreover, this finding now holds statistical weight at 10 sigma levels. In research lingo, this confirms authenticity, not a mistake or anomaly. For an organic icy body, such momentum would demand vast streams of vapor and particles erupting unevenly, thrusting the entity akin to miniature propulsion units. However, the volume of substance ejection required for this momentum fails to align perfectly with conventional icy body frameworks. A few investigators have subtly observed that should this be a manufactured item equipped with advanced boosters, considerably reduced ejection would suffice for identical outcomes. Traditional fuel-based or plasma-based boosters might generate the noted momentum with substantially decreased output. At this juncture, the account shifts to a heightened level of intensity. Based on fresh studies and path projections, 3 I/ATLAS might depart our stellar domain differently from its entry method. Researchers have identified an extraordinary feature regarding its forthcoming route, an aspect capable of transforming all perspectives. The wanderer heads toward a rendezvous with the massive planet's attractive field. Not an actual impact, but an event nearly as thrilling. Come March 16, 2026, projections show 3 I/ATLAS entering the zone where the colossal world's pull overtakes the sun's dominance. This attractive meeting could radically modify the wanderer's course, possibly redirecting its departure from our stellar group completely. Such an occurrence lacks precedent for a transstellar body. Never before have we witnessed this sort of world-to-visitor exchange with an arrival from external realms. The meeting might accelerate it, decelerate it, or divert its direction in manners unpredictable without additional information. Yet what renders this especially captivating is the exactness. Certain experts have determined that the entry into this attractive zone can be forecasted with precision surpassing 4 key figures. Such accuracy in path estimation stands out for any heavenly item, particularly one allegedly spinning across voids following expulsion from a remote stellar setup countless light years distant. Reflect on the implications. A body that journeyed through void expanses for conceivably eons, enduring innumerable attractive disruptions from transient stars, particle mists, and space remnants, nevertheless enters our domain with a course accurate enough to aim at the colossal planet's influence area with exceptional sharpness. Some label it chance. Others speculate if a purposeful element exists in this voyage. What remains certain is that this colossal planet meeting offers scholars a fantastic chance. The space agency's probe circling the gas behemoth may secure a prime viewing slot around the mid-2020s period. Envision a device crafted for examining the giant, possibly obtaining a premium position to observe a transstellar arrival's orbital waltz with our domain's biggest world. The consequences are profound. Should the probe monitor 3I/8TELS amid this meeting, we could gauge its reaction to the giant's pull with unmatched exactness. Any irregularities in its reaction, any unanticipated path adjustments or momentum shifts might yield essential insights on its inner makeup, weight spread, and indeed its authentic essence. But this is what maintains stargazers in suspense. The nearest passage by our homeworld arrives far earlier. On December 19, 2025, under 30 days hence, 3I/8TLS will skim within 269 million kilometers of our sphere. In universal scales, that counts as fairly near, sufficient for our strongest viewers to seize intricate records. Presently, global top facilities are gearing up for this window. The veteran orbital viewer and the advanced infrared observer are each being aligned to scrutinize this transstellar guest. This represents our optimal opportunity, maybe our sole one, to genuinely comprehend 3I/8TLS prior to its eternal departure from our vicinity. We seek more than aesthetic captures. Experts plan thorough light spectrum examinations to pinpoint the molecular makeup of the released vapors. They aim to quantify the precise velocity of these streams, ascertaining if we observe basic frozen water evaporation or an uncommon alternative. The information amassed in the winter month might ultimately resolve the accumulating inquiries since this body's identification, and those inquiries hold weight. Why does this icy visitor shine far brighter than anticipated? Basic frameworks forecasted a specific glow level considering its solar separation and projected dimensions. Yet 3I/8TLS has steadily surpassed those forecasts. Its radiance escalates at a pace implying either a highly unstable makeup dissimilar to any interstellar group or internal alterations beyond full comprehension. Studies from a notable viewing site and a military science lab measured this irregularity. They discovered the icy body's glow rising in reverse proportion to its solar distance elevated to 7.5 power. For context, icy bodies from our distant cloud reservoir usually display exponents from 2 to 4. 3I/8TLS nearly doubles that figure. What might provoke such intense illumination? A theory posits ultra-sensitive frozen layers, substances that gasify at far cooler levels than aqueous ice. Consider solidified gases like nitrogen or carbon-based ones, scarce in local icy visitors but possibly prevalent in void's chilly abysses. As 3I/8TLS neared our star, these elements could erupt vaporously, forming the vivid envelope and vast plumes we witness. An alternate idea concerns internal breakdown, maybe the body fragments, revealing new surfaces that bounce light more effectively. We have observed icy bodies shatter previously, yielding dramatic glow boosts, but 3I/8TLS's observed trends mismatch standard breakdown scenarios. And this is where discourse among experts grows truly engaging. A minor yet outspoken group of investigators proposes we avoid presuming 3I/8TLS is wholly organic, avoids baseless conjecture. It stems from reputable scholars highlighting the piling oddities as grounds for thorough evaluation of every option. The reasoning unfolds thus. We possess a body on an escape curve from void regions. It shows momentum beyond gravity, needing either huge substance loss or a superior drive system. Its glow pattern defies our frameworks. Its giant planet zone approach exhibits rare exactness. Those narrowly directed streams in latest snapshots, they appear much more concentrated and persistent than usual icy vapor release. To emphasize clarity, the vast bulk of stargazers trust organic reasons explain all observations. They contend our transstellar body frameworks, rely on merely 3 verified samples, too minimal to define norms versus outliers. Each fresh transstellar find demonstrates the cosmos' greater variety than envisioned. Yet, inquiries persist. Why marks this the third transstellar body identified? And why differ all 3 so markedly? Oumuamua appeared stretched and rotating with odd momentum. The second visitor seemed more typical yet retained distinct traits. And currently 3, I/ATLAS with its severe radiance and puzzling actions. What we observe truly is inquiry progressing, collecting facts, evaluating ideas, and staying receptive to evidence's direction. The winter examinations will prove vital. Light spectrum review can disclose the stream's molecular content. If composed of aqueous mist and standard gases, that bolsters the organic icy hypothesis. Detecting odd mixtures or release forms mismatching evaporation frameworks sparks fresh inquiries. Those streams' pace matters especially. Organic sunlight-driven evaporation yields vapor at foreseeable rates, often several hundred meters per second. Fuel-driven boosters would yield swifter exhaust. Advanced drive swifter yet. Through gauging substance velocity in streams, experts can restrict operating systems. Additionally, the icy body's core remains key. Despite numerous views, a distinct image of the central solid evades us. The envelope's brilliance veils the interior. The winter passage could alter that. With our world at minimal separation, premier instruments might penetrate the luminous shroud and perhaps capture the core straight. What awaits view? A jagged, uneven frozen rock mass like piers, or an item with surprising shapes? Clarity might fall short for all answers, but core form, scale, and light bounce data will aid riddle resolution. Concurrently, the schedule astonishes. 3. I/ATLS emerged on July 1st, 2025, affording stargazers mere months for nearest passage prep. Contrast with years, usually allotted for scheduling views of recurring local icy bodies. This tight time frame compelled the stargazing group to unmatched synergy and swift action. Global facilities share facts instantly. Home-based skywatchers with personal instruments supplied key views, refining the body's circuit. Cosmic organizations reshuffled viewing slots, prioritizing this unique event. It recalls that in questing cosmic vicinity answers, each watcher counts. Late autumn snapshots indicate 3 I/8LS stays vigorously active. That inward plume battling stellar breeze defies simple rationale. The substance flow needed to sustain such trait against stellar light and breeze thrust implies makeup vastly differing from local icy bodies or unknown mechanisms. A recurring point in expert talks is the pure ferocity observed. For the inward plume to advance over 1 million kilometers starward amid plasma at 400 kilometers per second demands dynamic force, surpassing stellar breeze by vast degrees. Suggests concentrations million times above baseline stellar breeze. That exceeds mild vapor release. It equals burst-like substance expulsion seldom witnessed. What's fueling this ferocity? If solely heat-based, if starlight merely heats sensitive frozen layers and bursts them to gas, the makeup must prove remarkably unusual. We possibly view substances plentiful near alternate stars but scarce locally. Such would render 3 I/8LAS research priceless. A specimen of alternate stellar chemistry. Yet another trend intrigues some scholars. The extra gravity momentum, directed streams, ongoing vigor. These lack randomness or disorder. Behavioral steadiness implies structured mechanisms over erratic bursts common in icy bodies tumbling and revealing varied faces to starlight. Ponder this. Typical icy bodies are uneven lumps spinning erratically orbiting the star. This prompts streams spraying varied ways, yielding a regular, fluctuating glow. But 3 I/ATLAS sustains notably constant vigor with narrowly directed streams. Such steadiness might signal uniform makeup warmed evenly, or suggest alternate, regulated aspects. That we engage these dialogues reveals our limited void knowledge. All in our stellar group arose from identical ancient gas dust veil 4.6 billion years past. We grasp that chemistry reasonably. But 3 I/ATLAS hails from separate stellar setup fully.
possibly one with utterly distinct molecular profile, formation tail, its evolution arc. Each metric potentially unveils alternate star conditions. Frozen layer proportions, organic presence, core density, and build. This data concerns unreachable locales we yearn to grasp. Thus, 3I/ATLAS transcends mere icy body. It serves as envoy from distant realm. Hence, winter views hold immense import. This marks our instance. 3I/ATLAS will graze our world, offer short chance window, then resume voyage. Post-giant planet meeting in spring. It flings outward, accelerating while ascending from star. In several years, it grows too remote and dim for mightiest viewers to follow. This sole chance gathers info perhaps absent for generations. Average gap between transstellar finds spans years, based on scant samples. Another might appear next period or delay 2 decades. We lack knowledge on visitor frequency or chance regularity. Such doubt mobilizes every capable facility. Land-based viewers in Pacific Isles, southern continents, European peaks coordinate viewing plans. Orbital viewers position meticulously. Even red planet circlers like the Continental Agency's gas tracer supplied key info via distinct perspectives, refining path estimates. Early fall views from a Mars setup proved especially useful. When 3I/ATLAS neared the red world, most within 9 million kilometers, the circler seized exact location metrics, boosting path forecasts tenfold. That decade-level precision gain enables assured giant planet zone meeting forecasts months ahead. This global teamwork and tech harmony embodies humankind's peak. Varied lands, entities, study groups unite for shared aim. Grasping an item owned by no single land, but all humanity as inquisitive beings pondering cosmic role. Lessons from 3I/ATLAS shape approaches to subsequent transstellar guests. Each find instructs on search targets, tool use, query poses. We craft guidelines for examining bodies traversing our stellar group en route elsewhere. Beyond direct research worth, profound elements unfold. Historically first, we regularly spot bodies from alternate star setups. Contemplate meanings. These exceed mere stones in frozen mass. They link physically to distant sites. Each particle in 3I/ATLAS formed an alternate stellar setup, circled alternate star, faced unimaginable conditions. Analyzing this body's makeup equates to viewing distant realm piece via tools. Atomic variant ratios, molecule forms, material traits, all convey data on 3I/ATLAS's birth setting. Did it arise near youthful warm star heavy element rich, aged cool star with alternate chemistry, paired star setup with intricate attractive motions? Such queries appear theoretical yet core to galaxy comprehension. Characterizing sufficient transstellar bodies enables mapping Milky Way's molecular variety, pattern spotting, stellar zone typing for body kinds, enhanced grasp of planetary setup creation like ours. Plus, here's what disturbs stargazers nocturnally: how numerous such bodies traverse our stellar group undetected presently. Our transstellar guest spotting advanced sharply lately via automated sky scans and superior find algorithms, yet we view merely surface. Brightest, vigorous bodies nearly self-declare. Per detected 3I/ATLAS, dozens or hundreds dimmer, calmer transstellar bodies might slip unnoticed. Some inactive icy without vapor for glow, others rocky reflecting scant light. We remain sightless to whole galactic rover populace. Hence, each finds import. Every transstellar body examined refines find techniques, signature comprehension, and more guest spotting. It forms cycle where finds boost subsequent likelihood. 3I/ATLAS's tail continues offering. Presently viewing this, the icy races to win or meet with worldly viewers. Stargazers finalize view timetables, tool tuning, prepping for potentially deepest transstellar body scrutiny ever. What might views disclose? Will confirmation show 3I/ATLAS exotic yet organic icy with odd makeup? Evidence of mechanisms defying current frameworks? Or find utterly unforeseen forcing total rethink on transstellar knowledge? Truthfully, uncertainty prevails, and that fuels excitement. This embodies genuine probing, live finding. We avoid distant star clusters or primordial cosmos light. This body resides in cosmic locale, near for detailed scrutiny, odd for assumption challenge. Winter learnings will echo years, likely generations. Such event shapes profession, motivates fresh scholar waves, broadens human cosmos comprehension. Thus monitor this realm. Track incoming updates. Winter views mere weeks distance, emerging info possibly extraordinary. We experience astronomy's landmark era. We join worldwide viewers seeing its progress. Prior to closing, recall joining Winds of Thought channel and activating alert icon. 3I/ATLAS AT last tale persists, fresh info arriving. We will dissect, interpret meanings, probe consequences gently. The universe hides endless enigmas waiting discovery. Post thoughts below. What believe you 3i/AT last truly represents? What excites most from winter views? If this thorough exploration proved worthwhile, distribute to space science aficionados. Such puzzles recall vast remaining knowledge, cosmos' immense oddity, our era's fortune studying alternate star visitors. Cosmos brims with marvels. 3i/AT emerges among the most captivating recent encounters. Hurtling our stellar group, bearing distant secrets, we prepare with viewers and tools, keen absorbing the stellar herald's revelations. This exemplifies inquiry's pinnacle. Humankind extending to contact unfamiliar, posing unimagined prior era queries, constructing wisdom per view. Gratitude for accompanying this exploration of 3i/AT recent evolutions. Till subsequent, maintain upward gaze. Interstellar visitors bridge worlds beyond imagination.